Hi everyone, welcome to my course on graph databases. So before even we go into the graph database, let's first understand how the databases have been evolved over last few years. So initially, a long time ago, when the computers were just starting, the data was stored in the punch cards actually, right? A little after that, uh, uh, relational databases were invented where data was stored in tables where each object, like for example in this particular example as you see in the picture on the right, each object is considered as a table and which has some properties, like for in this example cows is a table. It has a property like what breed it is, what sex it is, what is the birthday, who's the mother and father. And then the cows have ear tags. The ear tags are maintained in the different table, and then there is a many to many relationship between cows and ear tags. So that can is modeled by an intermediate table called cows ear tags, right? So this is how the table was stored, and there were a lot of databases that were modeling this kind of relationship, and like my SQL Server from Microsoft or Oracle databases were very popular. Those things. Some of the properties that the databases were supporting, like ACID properties, which where ACID is an abbreviation that stands for four properties. A stands for atomicity, C stands for consistency, EI stands for integrity, and D basically stands for retention, right? So uh, durability, sorry, D stands for durability, right? So basically these databases have transactional support. For example, let's say if you have a bank account where you are first debiting the account from one money and crediting into other, unless until both the operations are succeeded, the transaction is not considered as successful. So this is very important for a lot of use cases in real life. And usually the data is stored in a normalized manner, basically to avoid any repetition of the data. But that also means that you have to perform a lot of joins on this data. So this was okay for first few years where data was relatively small and we didn't have to perform a lot of joins. But as the data becomes large, as internet was becoming more and more popular, moving to clouds, the scaling became a challenge because relational databases don't scale well when the data exceeds like few terabytes. In these days, data is usually in form of petabytes, right? So relational data is not good solution for as the data becomes large, the querying becomes slow, and also as the relationship involves more and more objects, we have to apply more and more joins, and it becomes data querying becomes very slow. So for large data, what we did was mainly the bottleneck that was happening was the ACID property. So the ACID support was removed and transaction support was removed, and that's where the NoSQL revolution started, where the data now is stored in form of a key value pair, where each row in the database is identified by unique key, and the value could be any arbitrary object. It could be a document, or it could be a JSON structure, or it could be any binary object also. The database really doesn't care, right? But this structure allowed basically the ability to store a large value but did not allow any support for ACID properties. Also, this database also has a horizontal scaling capability where the same data can be stored in partitions across multiple databases, and also it can be replicated. I will explain that in next slide also. And the data is usually stored in the cloud, and the querying is a lot more faster in this particular case because data is already indexed by row key, and usually at any point in time we will be operating only on few row keys. Challenges are no ACID support, and also there is no relationship between the different tables. That's very challenging in case of NoSQL databases. So here is how the NoSQL can manage the scaling, where the database is partitioned across many nodes, and at the same time each data is also replicated across many replicas. So as far as the querying is concerned, since the load gets distributed between the main node and the replicas, and that's why the query become much faster. Also, since the data is partitioned at any point in time, when for a given query, when it comes, it probably knows the partition where the data is stored, and that's why at any point in time it will be basically searching for only few partitions, and that's why the querying is very fast. A NoSQL database typically also need to support an CAP theorem, right, which stands for as availability, consistency, and partitioning. And the CAP theorem states that at any point in time, a system can satisfy only 2 out of 3 properties. You cannot have a system which maintains all 3 properties. So here C stands for consistency. Basically what it means that whenever the data for a query comes, let's say if you want to find out how many employees are there in the Microsoft, the data will be partitioned into, the query will be sent to multiple servers, if the multiple customers are sending the same query, all of them should get back the exact same result. Availability indicates each client should always be able to read and write, they should not get any failures. And partitioning indicates that the system should work even if the nodes, there is a network failure between the neighboring nodes. And here on the for the each 2 properties, there are databases which optimizes those any 2 properties at any point in time. For example, MySQL RDBMS basically optimizes consistency and availability, whereas CP, basically consistent partitioning, is being optimized by Bigtable, MongoDB, Bug databases, and also availability and partitioning is usually optimized in case of certain databases like Cassandra, Dynamo, Walmart, Tokyo Cabinet, CouchDB, React, and Kai, right? So these are the different NoSQL databases. So enter now graph databases. So in the NoSQL databases, the challenges where you cannot have the relationship between the multiple database table. It's not that easy, right? So that's why again, but in many real life cases, like for example social networks, where we need the relationship support between the multiple tables, like for example here we have users which could be connected to other users, they could be friends or they could be connected as an office colleagues, and each of them have multiple properties, and there could be many such relationship, right? And also this data is very large. To satisfy those 2 constraints which traditional NoSQL did not have, the graph databases came into play. So graph database basically maintains the data in form of nodes and edges. Here as you can see, we have 2 persons, Alice and Bob, which are modeled as a node, and each of the node has properties. They have ID, name, and age. Also they are connected with each other, that Alice knows Bob, that's a relationship. And there is an also group of another node called group of people who play chess, and whether Alice and Bob are members, which is connected by this member relationship, right? And since when they are member, that is also captured. So this is how the data is stored in the graph database. Basically, it's a structure of nodes and edges. So and that way it can traverse the graph structures very easily. So irrespective of number of joins, the graph database queries perform very nicely. So basically it maintains any number of relationship, and it has the ACID support, right? So graph databases support the transactions as well. The queries are much faster, and it really represents the real world data as well. So these are the use cases for graph databases. The conventional belief is that the graph databases can be used only for social network, but that's not true. It could be also used for fraud detection, real-time recommendations, as well as network and IT operations. These are very popular. So in this course, we will basically learn about the graph database property. I will show you how to install neo4j. Then we will do a data modeling and just see how can we create a simple graph using nodes and edges. And then we will also learn about how to import the CSV data into neo4j, because a lot of times the real data is available in CSV and we need to understand how can we import it. Then we will go a detail into the cipher queries and see how we can create nodes edges, how can we aggregate the data, also how can we create the interesting relationship between the nodes, how we can unwind the nodes and all, how can we perform typical CRUD operations like create, read, update and delete operations. We will learn about that. And then we will also learn about how can we recommend, how can we build a recommendation like application using a movie like database. Okay, and then we will conclude with the next steps. So stay tuned.